Hello everyone, welcome to the mechanics class. In the last session, we have started the kinetics part. Kinetics means study of motion of a body, considering the forces acting on the body. Okay, um, and we understood a small part of it, which is a D'Alembert's principle. In that, we understood that D'Alembert's force is nothing but a inertia force or imaginary force which we have to apply on a moving body in order to achieve a dynamic equilibrium state and apply this. Then we can apply the equations of equilibrium to it in order to solve the problem, because without it, body is in motion, body is not in equilibrium, and we cannot apply the equations of equilibrium. Okay, and I think we have solved one or two questions on it. Yeah. So what we'll do is we'll understand some more concepts. Okay, because there are like there's work energy principle is also there. Then we have impulse momentum principle is also there. Okay, so let's try to understand these things first, and then at a time we will start solving questions on it randomly. So you have to figure it out. Um, then it will be more challenging for you to decide which um, of the theorem or which of the method you will use in order to solve that problem. Okay, rather than doing one method and problem then another method and problem, it's good to study these two methods first, that is work energy method and impulse momentum, okay, or principles, so that we can work on its problems. Okay, so write down heading work energy principle. You know work, you know energy. Okay, uh, so I'll not go into the small details like what is work and what is energy and all. Okay, let's try to understand the principle. Write down heading work energy principle or theorem. Just a minute. Okay, work energy principle. What is work done? Uh, just a small introduction. Work done. Work done means product of distance traveled by the body and the force applied in the direction of displacement, right? Yeah, it's a force into displacement. So which is F into D. What is F? Force applied in the direction of displacement, and D is a distance or distance traveled by body because of that force. Okay. So I'm saying that, let me just write it so that you'll understand. It's a product of distance traveled by the body and the force applied in the direction of displacement. Okay. Let me give a simple example. If we have this body, okay, W is the weight of body, N is the normal reaction in this case, and we are applying some force P to it at an angle of theta. Okay, and the body is moving in right hand side direction. This body is in motion. Okay, and travels a distance S. S is the distance traveled. Can you tell me what is the work done in this case? Yeah, it's a p cos theta into d. Okay, so remember, because the component of p in the direction of in the direction of distance travel is p cos of theta. So it's p cos of theta to d. Okay, or sorry, into s. S is the distance traveled, right? Yeah, p cos theta into s. Yeah, and what we are saying is work done, and we are talking about work. We are also talking about the energy. Okay, uh, what is potential energy? Potential energy is due to the position of the body, right? When, let's say, a body is kept at certain height, let's say h, then mgh will be its potential energy. So it's due to the position of body, we can say. Okay. But let's say the previous equation, whether the position of body is changing with respect to height, no, right? So we are will not be focusing on potential energy in that case. So what else we have? We have kinetic energy. What is kinetic energy? Energy gain due to rate of change of position with respect to time. Okay, so it's we can say energy gained by or gain due to rate of change of position with respect to time. Okay, or you can also call it as uh, half of half mv square, right? Is the kinetic energy. Generally, we use this equation. Okay, so what is the statement of work energy principle? Work energy principle states that when particle moves under the action of force, write down statement. When particle moves under the action of a force, the work done by the force is equal to the change in kinetic energy, change in kinetic energy of the particle. So that is work done is equal to change in Ke. Okay. So for example, we have one body, okay, which is initially at some velocity v1, and the lay after traveling a distance of, let's say, s, the, let's say, its velocity became v2. Okay, then you can actually find the work done from, let's say, during the distance traveled s is equal to change in the kinetic energy because of the change in this velocity. Okay, okay, so how it is came is like, f is equal to mass times acceleration. How can you write the acceleration? Dv by ds. um, dv by dt, sorry, dv by dt, change in velocity with respect to time, and but you can write it as dv by ds into ds by dt. Okay, and what is ds by dt? That is v. So mv into dv by ds, you can say, right? And now you can write f times ds is equal to mv times dv, right? You can write it like this. And if you integrate both the sides, let's say with respect to s1 to s2 distance traveled, and velocity changing from v1 to v2 in this distance, then f is a constant. F is not changing, we are changing the distance, that is s2 minus s1. S2 minus s1 is equal to mass times v2 minus v1. Okay, v2 mass, v2 square by 2 minus v1 is square by 2. So I 1 by 2 I'll take outside, v2 square minus v1 is square. Okay, so what is it basically? It is like uh, well, let's write it in detail. Half of m v2 square minus half of m v1 square. So what is this? This is a final kinetic energy, and this is initial kinetic energy. Okay, so work done is nothing but the change in kinetic energy. That is what we are saying, and this is how you can prove it. Okay, you don't have to remember this proof. You just, if you know what is this theorem, that's enough. But you should know how to apply it. Okay, just a minute, you can write it down. I'll drink water and come. Yeah, I hope you have written this. This is about the first theorem, that is our first principle, work energy principle. Okay, yeah. I hope you also know the principle of conservation of energy, right? As we are just studying this energy topic, I assume that you are aware of this. Let me just write a heading: principle of conservation of energy. I will give a statement of it. Uh, Statement is like this: sum of different energies in the universe remains constant. Sum of different energies in the universe remains constant. Or in other words, you can say that energy can neither be created nor destroyed. Energy can neither be produced nor destroyed, but can only change, or can only be changed from one form, can only be changed in from one form to other. Okay, and remains constant. Okay, so that is what we have been studying for a long time. What is law of principle of conservation of energy? Okay, so if we have a motion of a body, then sum of potential energy plus kinetic energy of the body, let's say, will remain constant during the motion. Let's say at position number one, potential energy plus kinetic energy we calculate, and it will be equal to the same thing, potential energy plus kinetic energy at, let's say, some another location. Okay, so your, let's say, potential energy may increase but kinetic energy will decrease, or let's say kinetic energy is increasing, it means your potential energy is reducing. Okay, yeah. So sum of potential energy and kinetic energy of the body remains constant during the motion of the action. Okay, uh, so let me just tell you what I'm trying to explain. Suppose we have a mass, let's say m, which is moving from this point um, A to point B. Okay, or let's say, yeah, from, let's start with A here and then comes down to B here. Okay, then what you can see is this point B is at height h2, point A is at height h1. So what you will expect here is at h1 we have the more potential energy, right? And h2, at h2 will have less potential energy, right? But how that potential, where that potential energy will go when mass m is moving down, as it is coming down, it will convert it into the kinetic energy, right? So basically potential in, so this is the first situation, potential energy plus kinetic energy at station 1 will be equal to potential energy plus kinetic energy at station 2. Okay, so this is what I'm talking about when it comes to the principle of conservation of energy. Okay, so in short, sum of the energy is also constant, or you can say, so this can be a statement, or another statement is summation of potential energy plus summation of kinetic energy is equal to constant. Okay, so this is also a statement. Any doubt till this? Is it clear to you all? Okay, another one simple, we have to study another theorem which is impulse momentum principle. Okay, impulse momentum principle. What is impulse? Anyone? Force into time, right? So impulse is the product of force and the time interval t. Okay, during which it is applied to the body. Okay, so generally an impulse is, you can say, a large force applied for a shorter duration of time. Okay, we can call it as impulse in day-to-day life. So basically it's a product of mass, sorry, it's a product of force F and the time interval. Okay, and the time interval t during which it is applied to the body. Okay, so you can say it as a large force applied for a short duration of time. applied for short duration of time. So it's F into T. Okay, that is the impulse. Now, what is momentum? Anyone? What is momentum? Mass times velocity. Yeah, it's defined as product of mass and velocity. Okay, the body in motion, and basically it's a vector quantity. Linear For linear motion, we say that linear momentum is given by mass times velocity. Okay, and what is this theorem now? We understood what is impulse. We understood what is momentum. Um, the theorem is about principle of impulse and linear momentum. So write down the statement of the theorem. Statement. It states that impulse of a force F during the time interval T is equal to the change in linear momentum, change in linear momentum of body in motion under the action of that force, under the action of that force. Okay, so that is impulse is equal to change in linear momentum. Okay, so we know force is equal to mass times acceleration. Okay, Newton's second law and of motion, and E can be written as dv by dt. So force time dt should be written as mass times dv. Okay, and if you integrate it from t1 to t2, okay, and the velocity is changing from v1 to v2 during that time, then force times t2 minus t1 is equal to mass times v2 minus v1. Okay, so force into t uh, is the impulse, and mv2 minus mv1 is final momentum minus initial momentum, that is change in the momentum. Okay, this is how you can prove it. Okay, is it clear? Another point is principle of conservation of linear momentum. like the principle of conservation of energy. Similarly, we have principle of conservation of linear momentum. Okay. The statement is total linear momentum of the system of bodies remains constant provided no external force no external force acts on the system. No external force acts on the system. That is, the total momentum of system is conserved if no external forces act on it. You can also write it like this: the total momentum of system is conserved if no external forces act on it. Okay. So in short, your initial momentum is equal to the final momentum. Okay. Yeah. So basically, whenever in case of, let's say, collision or impact of two bodies, the total linear momentum of the system before impact is exactly equal to the total linear momentum after the impact, right? You might have used this into the collision problems which you have studied previously. So that is what is based on the principle of conservation of linear momentum. Suppose mass 1 moving with velocity u1 and mass m2 moving with velocity u2 and so on. If they collide, then after collision, the it will be equal to mass times m1 v1 plus m2 v2 plus so on. So basically, total momentum of the system before and after remains constant. Okay, so that is what the principle of conservation of linear momentum says. I hope it is clear till this. If you have any doubt, feel free to ask. If no doubts, then you are ready for the problems. Uh, okay, let's take some questions. Yeah, determine the force required for moving the system shown in the figure by a distance 5 meter in order to gain gain a velocity v of 10 meters per second starting from rest. Okay, consider mu is equal to 0.2. Let's say the 300 Newton force we have here, or sorry, block we have, then 400 Newton block we have, and then we have 200 Newton block. We have an pulley here, and here as well. Okay, like this, and this is the ground. Okay, and this is making an 30-degree angle with the horizontal, and we are applying force P here. Okay, I'll repeat the question. Determine the force required for moving the system shown in the figure by a distance of 5 meters. Okay, in order to gain the velocity of 10 meters per second, starting from the rest. Consider mu is equal to 0.2. Yeah, so here mu is you have to consider for the block and the surface. Okay, the frictional force is in between block and the surface. You can neglect the friction of the pulley for block surface. So first of all, tell me, you have the D'Alembert's principle, impulse momentum principle, work energy principle. Which of these principle you will use to solve this question? How will you solve this question? Why you need G here, Abhishek? Why you need G? Keep it 9.81 if you want. Yeah. Okay, half m square you need. Fine. You can keep it 9.81. If nothing is given, always use 9.81. Okay. If specifically mentioned in the problem, assume G is equal to 10, then only you should use it as 10. Otherwise, use it 9.81. Okay. Okay, I'll wait for 1 more minute. You try to solve this question. Anyone solved it? Okay, spend some more time on it. Okay, we got answer from Abhishek here. Well, 1297. Yeah, your clothes, Abhishek. Yeah, maybe some uh, minor corrections, but yeah, 1286 is the correct answer in this case. Yeah, let's solve it. Yeah. So let's start with the free body diagrams of all the figures one by one, starting with the first 300 Newton box. Okay, so the weight is acting downward, 300 Newton. We have a normal reaction upward. We have a tension in the string, and we have force P applied in this direction, and we have frictional force in this direction as well because the system is moving in the leftward direction. So it's clear that the value of normal reaction is equal to weight, and that is equal to 300 Newton. Frictional force F1 is mu times N, and that is zero point 0.2 times 300, and that is 60 Newton. Okay, F1 is 60 Newton. As of now, we don't have any idea about P here, and that is our ultimate aim to calculate it. So we just got the value of F1. Fine. Coming towards the second free body diagram, little bit difficult compared to the first one. Yeah, okay. So now we have weight W2. W2, weight W2 is equal to 400 Newton. Then we have N2 here along this N2. Then we have tension side this T. Uh, when here we have W. So this is 30, means this has to be 30. The W sine of 30. Okay, we can write W sine 30. And the frictional force is also in this direction. Okay, and this side we have W cos of 30. Is it clear? Any doubt till this? Yeah, okay. If no doubt, then let's continue. Uh, N2 will be equal to Wy, that is W sine of cos of 30, and how much it will be? 400 into um, cos 30. I think it should be around 346.41. Just check it, confirm. Yeah. 400 cos of uh, 30. Yeah, 346.4 is the correct answer. Then we have F2, that is mu times N2, 0.2 times 346.41. It will give you 69.28 Newton. We got the value of F2. Coming towards the third figure, we have 200 Newton force apply, 200 Newton weight downward. We have normal reaction N3 here, okay, and we have tension again T, and we have the um, uh, F3. Okay, we have the F3. So frictional force for it. Let's call it as F as well. So what is the value of N3? N3 is equal to 200 Newton. F3 is equal to mu times N3. Or frictional force will be equal to 40 Newton, we can say directly. Okay. So all the frictional forces we got 60 Newton, 69.28 Newton, and 40 Newton. Okay. So if you look a system, how much force is applied in the direction of motion, basically. If you say work done is equal to change in kinetic energy, you know, and it is given that net force into displacement force, and how much is the distance travel? Distance is 5, right? Because they have clearly mentioned in the question that moving the system shown in the figure by a distance of 5 meter in order to gain a velocity of 10 meters per second, okay, from rest. So that is equal to change in kinetic energy, half of m v final square minus v initial square. So that is v final is 10 square minus 0 square. Okay. What is force here? P minus F1 minus F2 minus F3. So look at this. What are all forces are coming in the direction? One is frictional force here. Okay, let me use the red pen. Okay, frictional force, another frictional force, another frictional force, um, and also the component of weight of this 400 Newton, which is Wx. Okay, so it will look like this minus Wx, that is W. How much W sine of 30 or 400 sine 30, right? Yeah, 200. You can say multiply by 5 is equal to half of mass is 300 plus 400 plus 200 divided by 9.81, 10 square minus 0 square. Okay, and I think if you solve this, you have the values of F1, F2, F3. 1286 Newton you will get. Okay. Okay, any doubt in this question? Is it clear? Okay, we got question from Shrujana here. Why we considered the tension force? Uh, I am not considering tension force anywhere in the work done calculation, but in free body diagram, of course, you have to consider. Okay, why we do not consider? Because see, tension from this side will be equal to the tension from this side, right? Similarly, the tension from this side and this side will again same. What I already told you is like ignore the friction in between for the pulleys. Only consider the friction for block and surfaces, right? So basically, tension component we will have for all the uh, both the directions, and it will cancel it out. Okay, so you don't have to consider it. Is it clear, Sujana? Yeah. So only the frictional components will come into the picture. Okay, any other doubt? Is it clear to you all? Okay. If it is clear, let me give you another question. Okay, we got one question from Vikas. If we consider the all blocks in one system, how will you able to consider the this Vikas? Is it on the same straight line, or if it is there, then you can do it. But now it's at certain angle. Uh, Here these two systems are like horizontal, and the third system, which is in between, it is at inclined angle, so we cannot do it. Yep. So yeah, we cannot do it. If let's say if it is horizontal system, then let's say we can think of it, but in this case we cannot, because you can clearly see here the third, here the component of weight of the second block is coming into the picture. Okay, any other doubt? Yes, Sandeep, you can ask your doubt. You have raised your hand. Okay, if no doubt, then let's continue to the next question.
Hello.
Hello, yes.
Sir, why you put minus 400 sine 30?
Okay, here I mentioned all, here I drawn all the forces, okay, in the red, um, with the red arrow. Okay, so this is F1 is a frictional force in between block and the surface. F2 is a frictional force in between the second block and the surface. F3 is a frictional force in between third block and surface. Also Wx is along the same line. Okay, what is Wx? That is the component of weight. Weight is acting downward. Okay, Wy is like this, but Wx is along this, right? And Wx will try to oppose the um, motion of this 400 Newton in this direction of displacement, right? And that is why we have considered it. Okay, because in order to calculate the net force causing the distance, causing the displacement, we have to subtract all the forces which are restricting it, and Wx is one of them. Okay, not just the frictional force, but also the Wx. If the figure is horizontal, 300, 400 Newton, 200 Newton, so in this case only F1, F2, F3 will come. Okay, or you can try to combine it as well, but in this case you cannot, there is no chance of, or there is weight component will not come. But in our question, the weight component will come because it is along the line of motion, and that is opposing the net force. Is it clear? Hello, who was it? Is it clear to you?
Sir, yes. Yes, sir.
Okay,
Clear, sir.
okay, good. A ballistic pendulum consists of a sandbox, weight 262.43 Newton. Okay, suspended from, that is suspended from a cord 3.048 meter long. Okay, full stop. Okay, then we have a 4.448 Newton shell or bullet is fired horizontally in the box and in the box and remains in the box, or remains embedded in it, remains embedded in it, full stop. Because of because of impact, because of impact, the sandbox swings through a maximum angle (30°). Okay, as shown in the figure. The velocity with which the bullet strikes the box is the velocity with which bullet strikes the box is options 170 meters per second, 155 meters per second, 140 meters per second, option D 135 meters per second. Okay, I'll repeat the question. A ballistic pendulum consists of a sandbox of weight 262.43 Newton. Okay, so we have a pendulum like this whose weight is 262.43 Newton. Is suspended from a cord of length h is equal to 3.048 meter. Okay, another we have one shell, or you can say bullet, is fired, which is of weight 4.448 Newton with some velocity. Okay, Vs, let's call it as. Horizontally we are fired it, and it hits the box and remains embedded in the box because of the impact. Okay, and because of this impact, what will happen is this box will move upward, right? Swings upward with a maximum angle 30 degree. So this is 30 degree. Okay, something like this. Yes. So this is how the figure will look like. Yeah, maybe yeah yeah, solve this question. I'll wait for 2 3 minutes, and you spend some time on it on your own. um yeah, little bit big problem, but it will give you understanding of what we have studied till now in the kinetics. Okay. Yeah, spend some time on it. First, think of which method or which theorem you will apply in order to solve this question. They are using one word called impact. Uh, so means a little bit of about the impulse they are talking about. So use that logic, impulse momentum principle first, um, and then you have to find the velocity with which the shell strikes the box. Okay, or which the bullet strike the box. So that also you have to keep in mind. Yes. Okay, let me help you out in this. Yeah. So what I am saying is we have one sandbox of certain weight and a bullet which we are firing horizontally, it hits the box and remains embedded in the box. Okay, so we are doing some impact here, okay, or collision. um, so according to the impulse momentum uh, theorem, okay, it should it should strike your mind that something about the impact has to be used here, or collision you can say. The momentum should be conserved, so before impact momentum has to be equal to um, the momentum after the impact. So initially what I'll say is, let's say the mass m1 and the u1 is the velocity for the bullet plus mass m2, and u2 is the velocity of the, let's say, the box, and after the collision mass m1 v1 plus mass m2 v2 is the mass and velocity of the box and of the bullet and the box respectively. Okay, so this is basically in short before impact, and this is after impact. Okay, this is the momentum of the system. Now you know that the mass of the bullet is 4.448 divided by 9.81. Okay, and u1 is, let's say, that is what you have to calculate. Let's call it as vs because that is what's shown in the figure. Okay, so vs is the velocity of the bullet with which it strikes the uh, box. Okay, another we have box is 262.43 divided by 9.81 newton divided by 9.81 kg, but you know it is stationary, it is not moving. Okay, so velocity is 0, and that is equal to the after impact the total mass will be 4.448 plus 262.43 divided by 9.81 because the bullet is embedded in the box now. Okay, and everything moves with certain velocity, let's call it as v. Okay, so in short this 9.81 cancels out with this, so vs or 4.448 vs is equal to 266.88 times v. Okay, what is this vs? Velocity of velocity of bullet. Okay, velocity with which bullet strikes the box. Okay, and this is your question. So if you have to find this vs, in order to find this you should know v. What is v here? Can anyone tell me what is v? Velocity just after impact, right? Velocity after the impact, you can say. Is it clear? Anyone have any doubt till this? So if you know this v, you can calculate vs. Okay. Yeah. vs Vaibhav, no, I have given you options here: 170, 155, 140, and 135. So your answer looks wrong. Okay. Yes, Sanjeev, you are right. 170 is the correct answer. Good. So this is, I would say, first part of the problem. Half problem is half completed now. The second problem now is to find the v value. This we are interested in this v now, that is velocity after the impact. Okay, So part 2 of problem, I would say it will look like this, that after the impact, let me draw the figure again to explain you in detail. We have the box like this, and after some time, okay, it will look like this, and this is an angle of 30 degrees. So we know this h is what, 3.048. Okay, so this will be maybe more or less h1. Okay, and this hole is h. Okay, and this block is lifted by certain height, let's call it as s, and the weight of the block is here acting downward, here also acting downward, but here we have the bullet as well. Okay, which we have to consider. WB, WS, or W box. Okay, and here we call it as W. I hope you understood this figure now. Yes. Yeah, what is this h1? Uh, yes, this s is, you can say, as how much this h1 is, h1 will be your, I think, L cos of theta, you can say. Okay, that is h cos of theta, so 3.048 cos of 30 degree, and that you cancel from that you subtract from h to get the value of s. S is equal to h minus h1, and you should get 0.409, something like this. Okay, 0.409 something you will get. Okay, you know, work is done in this. Okay, because if force, because we are applying some, or let's say the box is moved upward with certain distances, we know work done is equal to change in kinetic energy, so force into displacement. So which is the force which is acting vertically? That is weight. So 262.432 plus 4.448, okay, into s. Okay, I'm considering negative sign because work is done against gravity, is equal to half of mv square again. So it is 262.432 plus 4.448 divided by 9.81 into initial final velocity is 0, because at this point the box will stop. Okay, I'm telling this point, at this point box will stop, and then again it will come down. So the kinetic energy at that point is 0, so it's 0 square minus v1 square. Okay, yeah. And what is this v1 v square? Basically, let's call it as v, a velocity of the just after the striking. That is what we are supposed to calculate. Once we calculate, we put it here and we'll get the vs. So basically you can cancel out this whole stuff, and distance is how much? Yes, we have already calculated 0.409, and from this you should be able to get the value of v, and I think it is 2.83 meters per second. Just check it. Okay, and you will put it into the first part of the question, that is 4.448 Vs is equal to 266.88 into 2.83, and you will get Vs is equal to 170 meters per second. Okay, do the calculation and let me know if something is wrong here. Yeah, I expect the answer will be very, very close to this 170, and yeah, little bit of differentiation is fine. Okay, yes, Ganesh, I'll explain you once again. Okay, let's start this problem. Okay, I'll explain you once again. Listen carefully. Okay. So they have given a pendulum like this, and to this pendulum, which is of weight 262.43 and the string length is 3.048, we are firing a bullet against it. Okay, horizontally. So what will happen is they'll collide. Initially, this box is stationary, but after the collision, box will move upward with an angle 30 degree. Okay, and this bullet is remained embedded inside the box. So they are telling upfront that this box after the impact moved by 30 degree. So can you tell me what is the velocity with which the bullet was striking the box? Okay, this is the question. So we started with the conservation of momentum because it's an impact problem or it's a collision problem. So momentum before impact of the system is equal to the momentum after the impact. So momentum before is 4.448 divided by 9.81 into the Vs. This is the momentum of the bullet. Okay, because mass is 4.448 divided by 9.81 into Vs is the velocity at which it is striking. And the second part is the velocity of the box. Box is stationary. Initially it is at rest basically, right? Or initially it is just hanging. It was not moving, right? So that is why we can say velocity is 0 here. But after the impact, the bullet will embedded into the box and both bullet and box starts moving. Okay, so and we don't know the velocity with which they start moving. So v is the velocity that which at which they start moving, for example. Okay, so from this we got this equation or relationship between the vs and v. Vs is the velocity with which bullet strikes the box, and v is the velocity just after the impact. I hope it is clear till this. Is it clear, Ganesh, till this? Any doubt? Okay, if no doubt, I'll proceed to the second part of this. We are interested now to find this value of v. V means velocity with which velocity just after the impact or the collision. So as we can clearly see here, the work done in order to move this box by a distance s vertically upward is equal to the change in kinetic energy. So what is work done? The total weight, which is the force which is acting downward. Okay, and the value is this 2.4 sorry 262.443, and let me just use the highlighter here. A minute. Yeah. Laser pointer I'll use to highlight. So here, this is um, the force, okay, and into the displacement s, that is we have just calculated. It is a difference between h1, it is difference between h and h1. H is 3.048 and h1 we just calculated 3.048 cos of 30. You'll get the value of s, multiply it here, is equal to half of m v2 square minus v1 square. The velocity of the box at this point, at the extreme point or the maximum angle 30 degree, will be 0. So that's why final velocity is 0. So 0 square minus initial velocity is what we have to calculate, v square, and you will get that through this equation as 2.83. And once you put it into this equation, you will get the value of velocity of bullet with which it is striking the box. Okay, any doubt? Okay, we are getting one question from Vidhi. Can we do by some principle of conservation of energy? Um, yeah, I think it should be possible. Okay, more or less you will get the same thing there. Okay, because you can clearly see mgh is equal to um, mgh, so kinetic energy plus potential energy at this point, point number A, and point number B. If you do an same equation, you will get and solve it. Okay, yeah, that approach will also be correct. Okay, any doubt, any other doubt? Okay. If no doubt, then we'll study another problem. And one. The 1 kg mass of clay moving with velocity of 10 meters per second strikes a stationary wheel uh, and sticks to it. The solid wheel has mass of 20 kg and a radius of 1 meter. Full stop. Assuming that the wheel and the ground are both rigid and are both rigid, and wheel is set into the pure rolling motion. The angular velocity of the wheel just of the wheel just after the impact is approximately. Okay. You got option. Okay, so this is the given data. Try to solve this question. Yeah, I will repeat the question in case you are finding it difficult. A 1 kg mass of clay is moving with a velocity of 10 meters per second, and it strikes the stationary wheel and sticks to it. The solid wheel has a mass of 20 kg and a radius of 1 meter. Assuming that wheel and the ground are both rigid and the wheel is set into the pure rolling motion, the angular velocity of the wheel just after the impact is approximately. Very simple question. I'll wait for a minute. You try to solve it. Anyone? Uh, Option B. Yeah, let me start sharing my screen. Yeah, actually, the slide on which I have written was gone now. We'll try to retrieve it later, but yeah, let's see. Let's maybe solve this question on the new fresh slide. Uh, I hope you can see my screen and hear me properly. So the question was, we have 1 kg mass of clay, okay, and that is moving with a 10 meters per second velocity, and it is hitting a wheel, okay, which is stationary, and it's 20 kgs of weight, and sticks to it. Okay, after this impact, the wheel is set into the pure rolling motion, and they're asking us to calculate the angular velocity of the wheel immediately after the impact. So it's a collision again impact. Momentum before is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, so it's the momentum of the clay, momentum of the wheel before impact, and the same as momentum of the clay and wheel after the impact. Okay, so it's a 1 kg moving with a 10 meters per second velocity plus 20 into 0 because the wheel is stationary, and that is equal to m1 plus m2, I would say, times v. Okay, because both are moving with the same velocity. So 1 plus 21, sorry, 1 plus 20 times velocity, okay, at which it is moving. Let's call it as v2. So here 10 is equal to 21 times v2. So this implies v2 is equal to 10 by 21 meters per second. Okay, so this is the velocity with which wheel is revolving. Okay, sorry, wheel is moving ahead. So this is the v2, you can say, after impact, and that is 10 by 21. I think they asked us the yes angular velocity, and angular velocity, it's r omega. So the value should be same because the radius is here, I think, given as 1, right? So it should be 10 by 21. So maybe the options are wrong here. I have written it mistakenly, but 10 by 21 radian per second looks correct. Okay, everyone got the same answer? Anyone have any doubt? Okay, let me give you another question. This is again from the previous year. A bullet of mass m travels at a very high velocity v as shown in the figure, and gets embedded inside the block of mass m. Okay, initially at rest. On our horizontal floor. The block with the bullet he seems to move distances along along floor, assuming mu, which is the coefficient of friction, kinetic friction between block and the floor, and g, the acceleration due to gravity. G, the acceleration due to gravity. What is the velocity? V of the bullet. What is the velocity V of the bullet? Okay, so your answer should be in the general form. Okay, I'll not give options. You try on your own, but I'm telling you that nothing is numerical here. Your answer is in the terms of m small. So this is capital M, mass of the uh, block. Okay, this is small m, mass of the bullet. Okay, v is the velocity which we have to calculate, and mu is the coefficient of the friction, and distance s is traveled. Okay, mu is the coefficient of friction, g is the acceleration due to gravity. Okay, so your answer is in terms of the small m, capital M, s, v, mu, g, etc. Okay, it's in general format. Try to solve this. I'll repeat the question to help you understand it. We have a bullet of mass small m. Okay, travels at a high velocity v as shown in the figure, and gets embedded inside the block of mass capital M, initially at rest on a rough horizontal surface or floor. The block with the bullet seems to move a distance s along the floor, so it moved by a distance s after the impact. Assuming mu, the coefficient of kinetic friction between the block and the floor, the g as acceleration due to gravity. What is the velocity v of the bullet? I hope the question is clear. Okay, I'll give you 2 minutes of time. Think on it and solve. So yeah, in the next session as well, we will dedicate it only for the problems. I'll pull some previous year questions or some other um, numericals, and we will spend next session only on these kind of problems. So from D'Alembert's work energy principle, impulse momentum principle, etc. Okay, and then later we will study the remaining topics, such as virtual work, principle of virtual work, and all. Okay, I think 1 or 2 topics are remain that um, we will cover after the problems. Okay, solve this question, not that difficult. So here again, collides. Okay, the word they have used. Okay, so basically there is again the collision of these two masses, small m and capital M. So I can say that uh, a mass small m traveling with velocity v plus mass capital M, which is at rest, is equal to small m plus capital M into the velocity final Vf. We can say Vf is the velocity just after the impact, right? So mv, the small mv is equal to capital M plus small m times Vf. Let's call it as equation number 1. From this you can directly get the value of v. Okay, but yeah, Vf you don't know. For that they have helped us with some other inputs. Okay, so this after the impact we have m plus m g, and normal reaction is n, and this is motion is in this direction, frictional force is in this direction, right? I hope it is clear till this. Yeah, but after the impact we don't have any force which is causing the motion. So kinematic equation you can use here: v square minus u square is equal to 2as. Final velocity is 0 because after traveling a distance of s it again came to rest. So 0 square minus initial velocity will be the final velocity after impact. Okay, so initial velocity of the motion will be the final velocity after impact. So that's what v up square I am using is equal to 2 okay to as and what is this say? Force is equal to mass times acceleration, right? um yeah so in this case what will be the value of uh, acceleration? So I would say mass plus small mass into acceleration is equal to frictional force. And what is that? Mu times g times mass plus m, right? Yeah. So mass times acceleration is equal to frictional force. And from this I would say A is equal to mu times g. Okay. Rather minus, I would say, because it's in the negative direction. So A is equal to minus mu g, right? And because it's a deceleration, it is starting with some high velocity and then coming to 0. So if you put it here, minus Vf square is equal to minus 2 mu gs. And from the first equation, what is Vf? Vf is equal to mass times velocity divided by capital M plus M. So if I put it into the second equation, mass times velocity divided by capital M plus small m whole square is equal to 2 mu gs. So V in this case will be capital M plus small m divided by small m into under root of 2 mu gs. Okay, so this is the final answer in this case. Okay, any doubt? Is it clear to you all? Yeah, we got one question from Abhishek. Why acceleration is negative? When acceleration is negative, what we call it, Abhishek? Deceleration, right? And is it decelerating in this um, uh, or RIA? You can also call it as retardation. Is it retardation scenario or acceleration scenario in this problem? After the impact, body is moving with some velocity Vf. Okay, both the bullet and the box and block, and it travels a distance s, right? Moves distance s. So after distance s, it's what is happening? It is stopped, right? So initially it is at certain velocity vs, and then it moved by vs. It moved by vs means after that it stopped. So whether the velocity here is reducing or increasing, it's reducing. So that's why it's a retardation or a deceleration, you can say, and minus sign I have considered. Yeah, you can consider through work energy principle. I am just giving alternatives. Here you can apply work energy as well. Okay, similar equation you should get, okay, out of it. If you have solved it through work energy, that's also very good. Okay, good. Yeah, then I think the only thing you have not calculated is acceleration, or only thing you don't have is g, I guess. Maybe you forgot to write there, but yeah, your answer also looks similar. Yeah, I hope it is clear to you all. Okay, we got one question from Ganesh, last to explain the last step. Okay, Ganesh, I will explain. Till equation number 2, is it clear to you? That is VFS minus VF square is equal to minus 2 mu GS. So minus minus gets cancelled, and VFS square is equal to 2 mu GS. Okay. And what is VF? VF is equal to, from first equation, mv divided by m plus m. So it is mv divided by capital M plus small m, and that is equal to 2 mu g. Yes. So we have square. So take a root on both the sides. So left will become mv divided by m plus m. That will be is equal to under root of 2 mu gs. Okay. And from this, mv will be equal to m plus m times 2 mu gs. And from that, v will be equal to m plus m divided by m under root of 2 mu gs. Okay. So this is how step by step you can think, but yeah, directly you can write it like this. Is it clear now? Yeah, okay. Okay, then let me give you another question. Yeah, we have some few more minutes. Let's take more question. Determine the velocity of the system shown in the figure when it moves by a distance of 3 meters starting from rest. First, consider pulley to be frictionless. Consider mu is equal to 0.3. Okay. For surface and block. Okay, I'll repeat the question. Determine the velocity of the system shown in the figure when it moves by a distance of 3 meters starting from the rest. Consider pulley to be frictionless, and the friction between surfaces and the block is 0.3. Okay, coefficient of friction, mu. Yeah, I'll give you 2 minutes of time, solve it, and post your answers in the chat box. Yeah, anyone solved it? It's not that difficult. Should be able to solve it. Okay, then let me help you out in this. Let's start with the free body diagram first. We have 400 Newton block, weight 400 Newton acting downwards. Normal reaction is upward. We have a tension on the right side, and we have the uh, frictional force uh, in this side, because um, motion is in the direction, right? Motion is rightward motion, so frictional force is in the left hand side direction. So what we can conclude out of it is the normal reaction is 400 Newton. The tension will be equal to um, yeah, basically we have more tension here uh, to than the friction force. That's why body is moving. Okay. So how much amount of frictional force we have? It's zero point 0.3 into 400. That is 120 Newton. This is the frictional force we have. Okay. We know work done is equal to change in kinetic energy as per work energy principle. If you look into the second block, it is 600 Newton is downward, and we have just the tension upward. Block is moving downward. Okay, so the force which is causing the motion is 600 minus 120, because the frictional force you have to subtract from it, into 3, and that is equal to half of m v2 square minus v1 square. That is 600 plus 400 divided by 9.81 into v up square minus final square, that is v up square, and initial velocity is 0, as they said, starting from the rest, and 3 is the distance they have mentioned. So from this you should be able to calculate vf. I think Sanjeev and Vikas, your answers are not correct. Should be something close to 5.31. Just check and confirm. Can you just calculate it and tell me the answer? Is it matching? So it is 600 minus 120, 480, multiply by 3, multiply by 2, multiply by 9.81, divided by 1000. Yeah, that's, yeah, 5.31 is the correct answer in this case. Yeah. Yes, okay. So yeah, that's all we have for today. In the next session, I will bring some more problems. And in the meantime, I'll start posting some more questions in the group. You try to solve, okay? And I'll post answers as well, in case you are not able to solve it, okay? But in the next session on Saturday, we will continue this, and we'll dedicate that session only for the problem solving. So do not miss it. And after that, we will maybe on Sunday we will study the remaining topics, which such as virtual work and one more. I think I'll check, and um, yeah. And later on we will uh, at the end, once the all the topics are covered, we will have a problem solving session. Okay, our practice session, a dedicated session for it will do, so that you will be familiar with all problems from the first topic till this last topic. Okay. um, I don't have JE advanced question papers, so Sanjeev, I'll try to get it, but yeah, I will definitely bring some previous year gate questions, and yeah, which you can expect. So that's all for today. Thank you all for joining this session, and let's meet again on weekend. Thank you all. Bye.